Hey guys, Vishnu here, and today I am going to explain how 5G works. So, before we get into this, I will be citing all the sources used for this video in the description. Also, make sure you watch my Wi-Fi video before this one. I will link it down in the description. Let's begin. 5G, as the name suggests, is a fifth generation of cellular networks. It follows on from 1G, 2G, 3G, and 4G. Each generation of cellular networks has provided better speeds and performance for communicating over the internet than its predecessor. Let's look at the features each generation provided in a moment. 1G was introduced in the 1980s and was able to deliver analog voice calling services to its customers. Analog signal is a continuous signal which can be visualized like a sine wave. 1G was the first wireless cellular network. A cellular network is a network where the connections are wireless. What this meant was radio phones could use 1G to communicate. The difference between landlines and these early mobile phones was that landlines used metal or optical fiber lines to transmit data, whereas these radio phones used radio waves to send and receive data. Japan was the first country to have 1G service nationwide. 2G allowed digital voice calling, which enabled encrypted calling and sending text messages. This generation was introduced in the early 1990s. 2G's download speeds maxed out at 250 kilobytes per second. 3G was a big accomplishment in cellular networking, for it allowed mobile data to be first implemented. It was also the first one to utilize high-speed packet access networks or HSPAs. The maximum download speeds were 14 to 15 Mbps. 3G was introduced in the early 2000s. 4G was by far the biggest jump in performance as it now used the LTE broadband. LTE stands for Long-Term Evolution Broadband and is based on GSM and HSPA technologies, which I mentioned earlier. GSM is the global system of mobile communication. 4G is the current generation of cellular networks. It is used by 85% of the whole population and can achieve maximum speeds of up to 1 Gbps. I have made a table to showcase the differences. All the previous networks have led to 5G. It is designed to provide even more connectivity than before and at higher speeds. But how exactly does it work? 5G operates in the same way as 4G but uses much higher radio frequencies. If you saw my Wi-Fi video, you will remember that these cellular networks use radio frequencies to send signals. The high-band 5G network, about which I will talk in a minute, uses frequencies from 28 GHz to 39 GHz. This is significantly bigger than 4G, which uses 700 MHz to 2.5 GHz. That is a gigantic 611% uplift in bandwidth. Now, 5G uses something called as millimeter waves. These waves were previously not used due to licensing and technological barriers, but are now being utilized by 5G. While these bands carry more information faster, they may have problems sending it over large distances. These frequencies are easily blocked out by buildings or trees. In order to get around this problem, 5G networks will use many input and output antenna to boost the frequencies across the whole wireless network. The network will also utilize 3 different methods of carrying data. These will be high band networks, medium band networks, and low band networks. High band networks will allow extremely high speeds but may have a tough time moving through hard surfaces. Mid-band networks won't allow super fast networking but will let the signal travel more. And finally, low-band networks will give a 20% increase in speeds than 4G and will also have a wide coverage area. In the real world, a low-band network will cover hundreds of kilometers and give speeds ranging from 30 to 250 Mbps. A mid-band network will cover several kilometer radius and give speeds from 100 to 1 Gbps. And lastly, a high-band network will give a 2 km or lower radius coverage from a single tower, that is, but will give speeds from 1 to 3 Gbps. Now you might say that these numbers sound wonderful, but what is the real advantage over 4G? The biggest advantage of 5G is the reduced latency. 5G has a theoretical latency of 1 millisecond as compared to 4G's 40 milliseconds. This will help you do things from a remote place in almost real time. This is really useful for people who are in the medical or technical fields where the difference of a millisecond can make a huge difference. The key thing to understand is that 5G isn't much faster than 4G on the same radio frequencies used by 4G. The thing that makes 5G faster is that it uses a wider broadband as compared to 4G and also allows more data to be sent. Think of it like highways. If 4G is a 6-lane highway, 5G is a 12-lane highway with even faster cars traveling on it. Also, you will need a 5G compatible phone for it to work. 5G is different from 4G and you can't simply enable it with a software update. It needs a separate module which is now being built in with chips nowadays. So, what is the downside to 5G? Well, the only downside right now, as of 2021, is access and the connectivity. As 5G is a millimeter wave frequency in extremely high bands, you may experience connection issues. For this, the providers will need to install a lot of towers in a small proximity for you to not experience dropouts. Note that these telecom companies will also have to purchase a lot of hardware to satisfy the existing customer base and also price it right to make it profitable with the hope that customers also adopt to 5G handsets quickly. So, contact your provider to see if the provider supports 5G or is planning to roll out. Companies estimate that by 2025, around half the mobile connections will be based on 5G. So, that's it. That's 5G in a nutshell. If you are watching this video in the future or on a 5G network, leave a comment down below saying watching in 5G and I will make sure to reply. Anyway, that's it for this video. Catch you all in the next one. Bye.